Dear students, welcome to today's class. Today we will be studying the two more questions of the 8th lesson. Here I omitted the cut portion questions and the other questions numbers are given in the textbook. Okay. The first question is an object contains more heat. Is it a right statement? If not, why? The answer is heat is the energy in transit and which flows from an object at a higher temperature to an object at a lower temperature. Heat is not a quantity. So, the statement an object has more heat is wrong. Instead, object is hot will be appropriate. The next question is define 1 mole. 1 mole is the amount of material containing 6.023 into 10 power 23 particles. Even if they are atoms or molecules, 1 mole will be containing just 6.023 into 10 power 23 particles. Next, ninth question of your textbook states Stefan Boltzmann law. Stefan Boltzmann law states that the total amount of heat radiated per second per unit area of a black body is directly proportional to the fourth power of its absolute temperature. ஒரு பிளாக் பாடியுடைய யூனிட் ஏரியாவிலிருந்து செகண்டுக்கு ப்ரொடியூஸ் ஆகக்கூடிய ரேடியேஷன் ஆனது டெம்பரேச்சருக்கு ஃபோர்த் பவருக்கு டைரக்ட்லி ப்ரொபோர்ஷனலாக இருக்கும். Then 10th question, what is Wien's law? Wien's law states that the wavelength of maximum intensity of emission of a black body radiation is inversely proportional to the absolute temperature of the black body. Next, define thermal conductivity. Give its unit. The amount of heat that flows per unit time through a unit area with a temperature gradient of 1 degree is called thermal conductivity. Its unit is watt per meter Kelvin. The next question is what is a black body? Black body is a surface that absorbs all radiant energy falling on it. The next question is what is a thermodynamic system? Give examples. Thermodynamic system is a finite part of the universe which is a collection of large number of particles specified by certain parameters called pressure, volume and temperature. Air cooler, refrigerator, etc. can be taken as example for a thermodynamic system. The next question is what are the different types of thermodynamic systems? The different types of thermodynamic systems are open system, closed system and isolated system. See, this is an example for an open system. This is a cup of tea which is opened and the heat energy can escape from the system easily. Now this is a cup of tea which is closed. So this is an example for closed system. This is a thermal flask and heat energy is trapped in the system. Thermal flask is isolated system. The next question is what is meant by state variable? Give example. The variables which completely describe the equilibrium state of a thermodynamic system are called as state variables. Example, pressure, temperature, etc. The next question is what are intensive and extensive variables? Give examples. Variable which depends on the size or mass of the system is called extensive variable. Example, volume, total mass, etc. Then variable which does not depend on the size or mass of the system is called an intensive variable. Example, temperature, pressure, etc. Temperature and pressure will never depend on the size or mass of the system, is it not? What is an equation of state? Give an example. The equation which connects the state variables in a specific manner is called the equation of state. Example PV equal to NKT, where N is Avogadro number, K is Boltzmann constant, and T is absolute temperature. State zeroth law of thermodynamics. Zeroth law of thermodynamics states that if two systems A and B are in thermal equilibrium with the third system C, then A and B are in thermal equilibrium with each other. Now define internal energy of a system. The internal energy of a thermodynamic system is the sum of kinetic and potential energies of all the molecules of the system with respect to the center of mass of the system. The next one is, are internal energy and heat energy the same? Explain. Internal energy and heat energy do not mean the same thing, but they are related. Internal energy is the energy stored in a body. It increases with the temperature of the body rises, or when the body changes from solid to liquid or from liquid to gas state. Whereas heat energy is the energy transferred from one body to another as a result of temperature difference. The next one is define 1 calorie. 1 calorie is defined as the amount of heat energy needed to raise the temperature of 1 gram of water by 1 degree Celsius at a pressure of 1 atmosphere. Did Joule convert mechanical energy to heat energy? Explain. Joule essentially converted mechanical energy into internal energy. In his experiment, potential energy is converted to the rotational kinetic energy of paddle wheel, and this rotational kinetic energy is converted to the internal energy of water. This is a simulation of Joule's experiment. Now state the first law of thermodynamics. Change in internal energy of the system is equal to the heat supplied to the system minus the work done by the system on the surrounding. This is the first law of thermodynamics. The next one is, can we measure the temperature of an object by touching it? No, we can't measure the temperature of an object by touching it. Temperature is the degree of hotness or coolness of a body. We can only sense the hotness or coolness of the object by touching it. Next, give the sign convention for Q and W. If the system gains heat, Q is positive. If the system loses heat, Q is negative. If work is done on the system, W is negative. If work is done by the system, W is positive. These are the sign conventions used in thermodynamics. Then define quasi-static process. A quasi-static process is an infinitely slow process in which the system changes its variables so slowly such that it remains in thermal, mechanical and chemical equilibrium with the surroundings throughout. Give the expression for the work done by the gas. The work done by the gas is W equal to integral of VI to VF PdV, where P is the pressure and dV is change in volume. The 29th question is, what is a PV diagram? PV diagram is a graph between pressure P and volume V of any system. It is used to calculate the amount of work done by the gas during expansion or on the gas during compression. Next question is, give the equation of state for an isothermal process. For an isothermal process, PV is a constant. The next question is, give an expression for the work done in an isothermal process. In an isothermal process, the work done W equal to mu RT natural logarithm of Vf by Vi. Next question number 34. Apply first law for an isothermal, adiabatic and isobaric process. According to the first law of thermodynamics, delta U equal to Q minus W. For an isothermal process, delta U equal to 0, therefore Q equal to W. Now let us apply first law of thermodynamics in adiabatic process. From the first law of thermodynamics, delta Q equal to delta U plus delta W. For an adiabatic process, delta Q equal to 0, hence delta W equal to minus delta U. Now let us apply the first law of thermodynamics in isobaric process. From the first law of thermodynamics, delta Q equal to delta U plus delta W. For an isobaric process, delta W equal to 0, therefore delta Q equal to delta U. The 35th question is, give the equation of state for an adiabatic process. For an adiabatic process, PV raised to gamma is a constant where gamma is the ratio of specific heat capacity at a constant pressure to the specific heat capacity at a constant volume. Next, give the equation of state for an isochoric process. For an isochoric process, P by T is a constant. Then question number 37. If the piston of a container is pushed fast inward, will the ideal gas equation be valid in the intermediate stage? If not, why? The answer is, when the piston is compressed so quickly that there is no time to exchange heat to the surrounding, the temperature of the gas increases rapidly. In this intermediate stage, the ideal gas equation be not valid because this equation relates the pressure, volume and temperature of the thermodynamic system at equilibrium. The next question is, draw the PV diagram for isothermal process, adiabatic process, isobaric process and isochoric process. Here there are two diagrams. The first one is for isothermal expansion and the second one is for isothermal compression. You can draw any one from this and you mention that for isothermal expansion or compression. Now adiabatic process. Here also two diagrams, adiabatic expansion and adiabatic compression. Now isobaric process. In isobaric process, pressure remains constant. So we will get a straight line and you can join the other two ends for change in volume. And here also isobaric expansion and isobaric compression are the two diagrams. Now isochoric process. In isochoric process, volume remains constant, so there is no expansion or compression, but pressure increases or decreases. The next one is, what is a cyclic process? Cyclic process is a thermodynamic process in which thermodynamic system returns to the initial state after undergoing a series of changes. The changes can be isothermal, isobaric, isochoric or adiabatic changes. Then question number 41. State Clausius form of second law of thermodynamics. Clausius states that it is impossible for heat to move by itself from a lower temperature reservoir to a higher temperature reservoir. That is, the flow of energy from low to high temperature is possible only when an external source for work is attached to the system. The next question is state Kelvin Planck statement of second law of thermodynamics. Kelvin Planck's statement is like this. It is impossible to construct a heat engine that operates in a cycle whose sole effect is to convert the heat completely into work. This implies that no heat engine in the universe can have 100% efficiency. So, constructing a machine with 100% efficiency is not possible. This is Kelvin Planck's statement. Next one is define heat engine. Heat engine is a device which takes heat as input and converts this heat into work by undergoing a cyclic process. The next question is what are the processes involved in a Carnot engine? In a Carnot engine, there are 4 processes involving. The first one is isothermal expansion, then adiabatic expansion, isothermal compression, and adiabatic compression. Then 45th question. Can the given heat energy be completely converted into work in a cyclic process? If not, when can the heat completely converted to work? Answer for the first question is no. And in a cyclic process, the complete heat energy is not completely converted to work. The whole heat cannot be converted into work as it will violate second law of thermodynamics. In an isothermal process, the whole heat can be converted into work. For an isothermal process, dq equal to dt, which shows that the whole heat can be converted into work. Now, state the second law of thermodynamics in terms of entropy. The second law of thermodynamics states that the total entropy of a system either increases or remains constant in any spontaneous process. It never decreases. Okay. The next is an interesting question. Why does heat flow from hot object to cold object? This is the question. The atoms in the hot bodies have higher kinetic energies than those of cold bodies. Thus, to maintain thermal equilibrium, the atoms of higher kinetic energy tries to move and collide with the atoms of low kinetic energy. Thus, heat transfers from hot body to a cold body. With this, all the 2 mark questions from your required portion is completed. Just go through them and study well.